Oh, goodness, it is not religion. Okay, there we go. Okay, so today we are doing our last objective of Unit 11, which means it is our last objective of the year. We are doing CO70. I can determine whether polygons are congruent or similar or neither. So congruent, similar, neither. So if we're doing our last objective today, it means we remember on Monday tomorrow's Friday. Tomorrow is our silent cheer fiesta fun that we are having. Then Monday there is no school because it is Memorial Day. Tuesday will be a review of all of. Do you guys want to do a review on Tuesday, or just want to do the practice test? Raise your hand if you think you need a review time after a long week. Well, here's the thing. We do have the whole week, but we also have stuff packed into that whole week. So Wednesday we've got the market day, we've got 8th grade graduation awards. So we will, okay, I've got it planned out, figured out. We'll do a review on Tuesday, practice test on Wednesday, so that way we don't have to try to remember everything after a long weekend. I don't want to make anybody have to study on the long weekend. We should be thinking of the soldiers that we are remembering for Memorial Day. Thursday will be the test. So we'll do a review day, practice test, then real test on Thursday. Friday of next week will be track and field day. And then that last week of school, if there are retakes that people want to do, we will do retakes. If we have no retakes, we will do some math fun.
What are we going to do on last week?
I literally just got done telling you what we were going to do the last week of school.
Retakes and fun things like that.
So yeah, so let's focus. CO70, last objective. I can determine whether polygons are congruent, similar, or neither. So let's see what this means. We should know what the word congruent means. That's our lovely vocab word that I make us use. What does congruent mean, Paul?
It's equal and same.
Equal. It's the same. So congruent polygons are polygons that are same shape and same size. All sides and angles are congruent. So an example would be well, I'm not doing very good drawing freehand like this, but let's say A, B, C, and D, W, X, Y, and Z. I would say A, B, C, D is congruent to W, X, Y, Z. So this symbol right here, the equal sign with the squiggle above it, means they are congruent. They are identical. Same shape, same size. Everything is the same measurement. Angles, same measurement. Sides are same measurement. So when you see the equal sign with the squiggle, means it's congruent. So list the pairs of corresponding sides. So what do you think that means?
Like list the letters that are on the same side.
The letters that are congruent. That is, so we want the line segments that are congruent. So if I have AB, what is AB congruent to? Daddy? WX. So then I have BC is congruent to what?
XY.
XY. CD is congruent to what? YZ. And DA is congruent to what? ZW. Okay, that's congruent. You feel good about congruent?
Yeah.
All right, so let's look at similar polygons. Let me move it up. What do you think a similar polygon is? Any guesses? Ryan.
It's like each side, like let's say like a rectangle has like its height is like 4, its side lengths are like 12. And there's another one that has like that its side length is 4 and like 1.
You're close. Close, but not quite. What do you think, Izzy?
Are they the same shape but different size?
Same shape, different size. So the measurements you were giving me, Ryan, they weren't proportionate. So that means they wouldn't be the exact same shape. Okay, so your numbers would have to be proportionate.
I didn't know.
Yes. So similar polygons are polygons that are same shape, but different sizes. So the example that Ryan had given with the numbers of the measurements of the sides, they weren't proportionate. So it meant that the rectangle shapes wouldn't be the exact same style of rectangle. So the example Ryan gave was this is 4 and this is 12. And then he said then the next one would be 1 and 4.
I meant to say.
So it wasn't quite proportionate. So it would have to be 1 and 1 to make it proportionate. 3. Then that would be an example of it. Okay. So the rest of it are angles. Oops, that is not a G. Angles are congruent. Sides are proportionate. Proportional. So it's taking that same shape and it's either shrinking it down or expanding it bigger, but it's the same shape. So an example, let's say this triangle, that's A, B, C, has 8, 14, 18, and then this triangle is X, Y, Z, and it is 4, 7, and 9. So we can see our sides are proportional. I'm dividing each side by 2. I'm shrinking it down by 2. They are proportionate. Our angles, we have angle A, angle X are congruent, angle B, angle Y are congruent, and angle C, and angle Z. Notice how I'm putting more lines so we don't get confused about which ones are congruent. So only the angles with the 1 line are congruent, the angles with the 2 lines are congruent with each other, and the angles with the 3 lines are congruent with each other. I couldn't just put 1 line for each angle, because then that would say it was equilateral and they were all congruent or equal angular. Does that make sense with the angles? So let's look at our pairs of corresponding sides that are proportionate with each other. You know, before we do that, he didn't put it on there, but triangle ABC is similar to triangle XYZ. So when they were congruent, it had the equal sign with the squiggle. When they are similar, it just has the squiggle. So that means that they're proportionate. They're not the same size, but they are the same shape. Their angles match up. List the pairs of corresponding sides. So if I have segment A, side AB is similar to what side? XY. So then side BC is similar to what side? YZ. And side CA is similar to side ZX. And what we could do is we could put it in our proportions. We could say AB over XY equals BC over YZ, which equals CA over ZX. So if we put the numbers in, 8 over 4 equals 14 over 7 equals 18 over 9. That's how we know they are proportionate. We find the proportions of our sides. We know AB matches up with XY, so we can say AB over XY, 8 over 4, gives us 2. 8 divided by 4 is a 2. So then we match up BC over YZ, that's 14 over 7. 14 divided by 7 is 2. CA over ZX, 18 over 9. 18 divided by 9 is 2. They all have 2 as their ratio. So that's how we know that they are similar. They have the same ratio. They are proportionate. Make sense? So let's bring in back something that we learned about a while ago, and we're using it again with those proportions. So that becomes important when we're determining whether the polygons are congruent, similar, or neither. So it is important that you check to make sure if they are proportionate. It's going to be easy to see if they're congruent. Why is that going to be the easiest one? Joseph?
Because they're gonna look exactly the same.
They're going to be exactly the same. Okay, so if it's congruent, they are identical. That's the easy one. You need to figure out the similar and the neither. Are they proportionate? So when you put in your proportions, do they all equal each other, the proportions of each side? So let's look down at the bottom of this page. I'm going to scroll up. Determine whether the polygons are congruent, similar, or neither. So, do they have to be looking in the identical terms to be congruent or similar? Could we have something turned and it still be congruent? Yeah, because we've talked about the flips and the slides and all of that. It doesn't have to be facing the exact same ways. You have to match up sides and angles. So if we look at number 1, or it's not numbered, but we look at this first one. We have a triangle with sides of 12, 15, 9, 4, 5, and 3. Is it congruent, similar, or neither? Chase.
They're similar because all the sides are proportional by 3.
So you have to prove it. So you can't just write similar. You have to show your proportions. Okay? We can never just look at it and say, yeah, I think it is. Looks similar to me, and write similar. You have to do the math. So we're gonna match it up. So this side matches up with this side. So that would be 12/4. We're saying that is equal to 15/5, which would be equal to 9/3. Because if we're starting with this triangle on top, every one of these sides needs to have that triangle on top. Then the small triangle needs to be on the bottom. 12 divided by 4 is 3. 15 divided by 5 is 3. 9 divided by 3 is 3. So we know it is similar. But you have to do the math. Did you write it down, Gavin? So make sure you're showing your proportions and make sure they actually equal each other. When you write out your proportions, if they don't equal, then you know it's a neither. Look at our next set of polygons. Congruent, similar, or neither. What do you think, Edward? Yeah, we have one that's turned. It's upside down compared to this one, but all of their measurements match up. 6 and 6, 19 and 19, 19 and 19, 22 and 22. They all match, so it is congruent. I am going to have you do the next page on your own. So you're going to draw and label. So make sure, think about the examples I gave. How do we show the angles are congruent? How do we show sides are congruent? Put in numbers to show that it is a neither or it's similar. Then determine whether the polygons are, then you actually have to do the math. So if it's neither or similar, do the proportions and show that they are not proportionate or they are proportionate. And then we have our review on the bottom, helping us get ready for next week. So for my friends at home, we hope you are well, and we hope to see you soon.